Carbon number 2 of the fructose attack the carbon number 5. Carbon number 2 attack the carbon number 5. The O is between. You see, understand me? 1, 2, 3, 4, 5.
What do you mean
6.
by attack? Do you mean like water is?
It means hemiketal formation. Why I understand hemiketal? Because the ketone attack to the alcohol is hemiketal. What is the characteristic of hemiketal? See here. Hemiketal has the OH, R. See this carbon? Show it. That's good. You see this carbon has a OH.
R.
This is one R. The other R.
Yeah.
And OR. What's that? This is a hemiketal. Hemiketal. Because of the reaction between ketone and alcohol. Now, what's happened if the carbon number 2 attack and make a reaction with carbon number 6? See this one? This is number 1, number 2, number 3, 4, 5, 6. Between 2 and 6. 2 and 6. The hexose is produced. If, I explain here, if carbon 2 react with carbon 5, the production are furanose. Yes? If carbon 2 react with carbon 6, the production are pyranose. And what does it mean, furanose? Furanose is 5-member ring. Pyranose is 6-member ring. But they are very rare. Again, this carbon is acetal or ketal. We should understand. This is OH, R, OR. This is again hemiketal. Good? But 90% we see the fructose on this structure. Why this OH is above, this OH is down? You see on the fructose, carbon 3 is left. Left means inside the cycle. Carbon number 1, 2, 3.
Outside.
No, this is inside the cycle.
Oh, this one.
So when it's
1,
upwards, it
2,
means it's inside
3.
the cycle?
Yes. Left means inside the cycle.
Okay.
Do you understand it? Good.
Yeah, because
Why this is D? Because the carbon number 5, 1 to the last, is in the right hand. Because of that, this is D. Why this is alpha? Because CH2OH is
down.
No, because the OH is down.
Yeah.
OH is
Down.
And this is in the transposition with carbon number 6. Alpha is a OH down in transposition with carbon number 6.
But you said it's D because
The carbon 1 to the last is in the right hand, dextero.
the OH is on the right side.
Yes, OH is in the right side. One to
On the
left.
fifth one. This is the fifth one, no?
Yes, that's the fifth one, and the OH, the oxygen, this oxygen.
Do they make water?
Yes, it's make a water and it's go.
Okay. Alright.
No, the conformation of pyranose. For sure, the pyranose is such like a cyclohexane. Cyclohexane, we have a boat and chair. The boat was unstable. Why? Because of the occupancy and near thing. You see, if this is a boat, this is not stable, unstable. But these two, it was a C4 to 1. 4 is above, 1 is down, and it was a C1 to 4. Do you remember such like this?
Yes.
Last semester?
Yeah.
Now, what does it mean axial? What does it mean equatorial?
Axial means it's up or down. Equatorial means it's on the line.
Yes,
Horizontal.
axial is a 90-degree perpendicular. Axial is horizontal. Again, axial is perpendicular and equatorial is horizontal. Good? Now, alpha D-glucopyranose, that's not important
Why
for
is it
us.
so important that we have to know what's axial?
Later you learn the different modification on the glucose, and that's just one of them is important.
I think it was one
For
of the
understanding.
lists.
Yeah, for understanding. No, here.
Biochemistry. There's like
That's
one
very,
and the
very
X one is
important.
aqua and this one is
Very important. Pinkish for Lisa. Muta rotation. What?
Muta rotation.
Muta rotation. It's very difficult also. First of all, see this one, that's an open chain 4. In the body, is it alpha D-glucopyranose or is it beta D-glucopyranose?
Better.
I don't know. We should understand it. See, in beta D-glucopyranose, all of them, you see, give it to me, I take it. In the beta D-glucopyranose, all of the OH group and the CH2OH group are equatorial. On the beta D, this is a beta D, all of the OH and CH2 are equatorial. It means none of them are axial. See? This is the most favored energetically. That's a very important sentence. In beta D-glucopyranose, everything is equatorial, everything, and this is most favored energetically. Why? If they are axial, I told you this is perpendicular, yeah? Imagine that this is a stand here, the other one a stand downside. That's the pressure on the cycle. The cycle doesn't like. But if this is like that, the other one is like that, they are very good. They would like to be together on the cycle. This is not so much pressure. If I stand on the table is break. But if I lay down on there and so I put my leg such like this, not exactly on that, there's a low pressure on the cycle. Can you imagine? Yeah? Again, on the beta D-glucopyranose is most favored energetically. Why? Because everything is equatorial. Just the explanation, not the rowing. Not just explanation. The specific rotation value of the anomer. What does it mean, anomer? Anomer is alpha beta. The different position on carbon number 1. In the first carbon, okay? The different unit until an equilibrium is established and reach the equilibrium value of 52.7. Now, what does it mean? They do you practice on the biophysics by polarimetry?
I didn't have that.
Polarization microscope?
Yeah, I did that.
Do you measure the angle?
Yeah, I did the diffractive index or whatever it was.
Yes.
Yeah.
Refractive index is something else.
Yeah, but the angle, what was this?
You see, it's such a microscope like this,
What is
by one column.
angle of rotation.
You put the glucose there, you
Yeah.
close the end and top, you put it on the instrument. You the sodium flame is turned on, or sodium lamp. The light is coming here, and you just measure the
It's to find the
rotation
Yeah.
of the polarized light. That's
Yeah.
a polarized microscope.
Yeah, rotation angle.
Yeah, polarized micro. You have it also on the biology, I think. You have it last semester, I'm sure. And you measure the alpha, and you have a specific rotation and rotation angle.
No, we
No,
didn't.
only in biophysics.
in biology.
Yeah, in biology.
Lab?
In the chemistry also you have it.
No, we didn't have that. for
Only in
sure.
biophysics.
On chemistry you have it.
No,
Where
I would
no?
have remembered if we done this. I remember last.
Only in biophysics.
Yeah.
Yeah.
I'm sure on chemistry you have it.
No.
Polarization, alpha, specific rotation. You see, specific. Why do you laughing? Specific rotation is 100 alpha divided by CL.
You hear yourself now?
Do you remember this one?
We didn't have that for sure.
That's what I'm talking about.
What's happened?
I don't know.
I don't know. She's
'Cause-
crazy.
Every single time she says no, she doesn't say no. She says no.
I think they ate the X. They want to go to party after the class. Yeah. Or that's the effect of the chocolate with alcohol. Yeah, maybe.
What did you put in the chocolate?
What?
What did you put in the chocolate?
Me?
It was
Nothing.
right
No,
inside.
Aisha put something
I
there.
put something LSD inside.
Anyway, that's a very important formula.
Yeah.
The name of that is a specific rotation,
Yeah.
100 times alpha divided by CL. And as I am sure, it was an MRT question last semester.
We did it.
No.
For
Trust
sure.
me, it wasn't.
Believe me, I
No.
wrote all of them.
Yeah, and I read
No.
all of
It
them.
was
No.
not.
But
Only
that's very
biophysics.
important. Every time it comes on the biophysics,
this
biology,
semester.
and chemistry.
But I think we did it to find concentration.
Yes,
Yeah.
You had it, I'm sure.
I only biophysics.
Only biophysics.
Only
And I
biophysics.
haven't
I
done
didn't
it yet.
have that because I was in the other room.
Yeah.
Me too.
No. Anyway, that's a polarized microscope. The alpha is important, alpha angle, and this is a rotation. It means the polarized light come. I have an enantiomer, chirality, and it can rotate the polarized light. I measure this angle. And I always said they measure for the cocaine. Do you remember?
Yeah.
Now you remember something, yes?
I remember that,
And-
but we didn't do it.
And if this is not the exactly pure one, boom, boom, kill. Okay?
Can I say something?
Yes.
I saw a movie yesterday and they did that. And I was thinking about that.
No.
They killed
See?
each other.
The alpha glucose can rotate the light 112. The beta D glucose can rotate the light 18 degree. It's less. But the combination should be 112 plus 18 divided by 2. But this is not look like that. This is 52.7. Why? Because the beta D is most favored, the percentage of beta is 64%. And that alpha is 36%. It means I should say 36% multiplied by 112 plus 64% multiplied by 18.7 divided by 2.
Do we have to know this?
No, not the number. You should understand it.
Can you explain
Again, one sentence. The beta D glucopyranose is most favored energetically. It has a less rotation. And in the opposite side, alpha D is not favored and it has a high rotation of angle of the polarized light. But the average is near to 52.7. It is much more near to this number as this number. If you decrease this, you said this is very far. If you decrease this, is so near to beta D. Why? Because just on the exam, because the percentage of the beta anomer is more than alpha. Percentage of beta anomer is more than alpha, not the number. You don't need the number. Just remember it's more than that. And it's sitting because there is no rotation here. 0.02% is also open chain form. Who cares? It means actually we should plus 0 and divided by 3 because they are 3, 4. Average to get the average. Such like this. I hope that you understand it. It always comes to the exam 100%. What does it mean with rotation? Just you should draw beta D and alpha D, and I'm sure that you cannot draw it exactly like that. Just mention that all of them are equatorial.
I have a question.
Yes.
Like if they say draw blah 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 with rotation, can you draw another compound than the glucopyranose?
What?
Does it always have to be this compound?
I don't understand again.
For example, they give you a question in the exam about this.
They just
Does it
ask
always
you.
have to be this one?
Yeah. You see, they ask it, what does it mean with rotation? And if I am instead of you, in the answer, I draw it one glucose such like this, and beta is OH above. This OH is above, down, down. I wrote that's a beta, all of them are equatorial. And for the alpha, I draw such like this, OH is down, CH2OH, down. And I said this is the alpha, and all of them are equatorial and axial mix. And I get the 4 point or 5 point.
What did you say?
You cannot draw it exactly like that. Draw the simple beta and alpha. Explain it. Beta is most favored. Beta has, all of them are equatorial. Beta has a less rotation of angle. I hope you get it. No.
I get it.
Where's our face?
Here.
Okay.
Oxidation of monosaccharide. Oxidation of monosaccharide. Very, very important. Very important.
Oxidation.
Okay. Just don't.
Sorry.
This one? Yeah.
You lose age.
Alpha or beta? Because of that, we don't know exactly alpha or beta is put it such like this. Okay, the fucking, who care? You know the primary alcohol could be oxidized too, Aisha?
Primary alcohol?
Yes, oxidized too.
Aldehyde.
Yes, and aldehyde oxidized to
Carboxylic acid.
acid. Sabina, is it possible that the alcohol oxidizes to acid directly?
Yes.
How?
By loose
By
oxidation twice
the
at the same time.
esterine oxidizing agent. By the esterine oxidizing agent, it's go directly to the acid. What's happened? Forget this structure, actually fuck that, and draw one glucose for yourself. 1, 2, 3, 4, 5, 6. OH is left, OH is right, 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 right. H2, H, 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 H. Good. The aldehyde could be oxidized to
Carboxyl.
acid. Okay, it's oxidized. This one is oxidized to that. But the alcohol could be oxidized directly to acid also. Yeah? It's the esterine oxidation. It's what? Esterine?
Oxidizing.
No, the name is so fucking. See? Gluconic acid, glucaric acid. And the other name is aldonic acid, aldaric acid. How should I remember that?
Oh.
Yeah.
Max Schiffer.
Yes. I want to tell you something. Carboxylic acid. Again, carboxylic acid has a O. Carboxylic acid. I have a glucose. And glucose with acid, it's like a carboxylic acid. It will be gluconic acid. Again, I want to explain it. Glucose with carboxylic acid
Gluno.
will be gluconic acid. They are a lot. Later you learn something else also. Okay, just learn now gluconic acid. Now how about the glucaric acid? You know the car means car driving. Driving car has how many chair on the two. It means it has 2 carboxyl.
Okay.
Glucaric, it means the glucose, and because this is car, it should have a 2 carboxyl group. Can you remember it now?
Yeah,
Good?
I can remember. You traumatized me
Glucose
right now, so I can remember.
with car.
What does it mean with car?
You see, this is a car.
You know you drive a car, right? In the front you have 2 seats.
This is a car, and this is a 2-seat here. It means 2 carboxylic acid. Aisha, they are a lot. They are very difficult. You cannot memorize all of them. Just by laughing, you can memorize something. Glucaric is glucose with 2 carboxyl. Gluconic, glucose with 1 carboxylic.
Gluconic only
carboxylic.
Yeah.
Glucaric, 2 carboxyl. Now,
What is it called when it's 2 carboxylic group? What is the function? Like for
no, what is the function? They are a lot. On the drug and pharmacology, you learn a lot about them. Just know this part, that's enough. That's the basic.
What would they ask? Like,
Glycerol, the gluconic and glucaric acid. And what is the relationship between them with glucose? The glucose oxidized to this one is oxidized to that one. What is the function for metabolizing the drug? Okay, you learn it on pharmacology that which drug by this one. If somebody has a diabetes, it means a lot of sugar, the drug will be metabolized very fast. Why? Because there is a lot of sugar, there is a lot of gluconic and glucaric acid, and they can catch up the drug and waste. Understand? You learn it later. That's a very large story, 2 PDF, 4 hours. Now, the reaction of carbonyl group.
Yeah.
The carbonyl group could be reduced, could be oxidized. Last year on the exam, they asked it about 30 point on the final, and ask, please write the reaction of carbonyl group on the aldose. Okay, first of all reduction, then oxidation, and they should draw everything and they get the point. Understand? It means the reaction of carbonyl group is important, and it's exactly what in the exam with 30 point. Can you imagine? 30
what
point?
is just this
But just this is 5, 4, 4, 4, 4, 4, 4, 4. It's a lot.
which one? Show again with the camera.
You see the reaction of the carbonyl group. You should draw this page completely and this page completely.
Wow.
Now, tell me, the primary alcohol oxidized to Aldehyde. The aldehyde could be reduced to primary.
Again.
Okay, now what is the name of that? Glucose with aldehyde group. It plus 2 hydrogen means reduction. Aldehyde oxidized to alcohol. The name of that is sorbitol. Later you learn, and now you should understand, what is the sorbitol? Sorbitol is a sugar alcohol.
Sorbet.
Sorbitol.
It's like
And
a sugar
mannitol is also sugar alcohol. And both of them are laxative. What?
Oh, really?
They are...
No, this one doesn't work.
They make you poo-poo.
No, I said wrongly. They are osmotic diuretic.
They make you pee-pee?
No. Osmotic diuretic.
What is it?
It means if the patient has a high blood pressure, they should get the diuretic to urinate a lot to decrease the blood pressure.
Yeah, the pee-pee.
Pee-pee? I don't know. Pee-pee, urinate, okay? No. What's that? This is a fructose. Fructose has a ketone. Ketone, if the ketone is reduced, what is produced?
Secondary alcohol.
Secondary alcohol. But it depends. It depends that is reduced and produce OH on the left or produce OH on the right. If it's reduced and produce OH on the left, it means the carbon number 2 and 3 is left. This is a mannitol. Why? Because here you learn that the mannose is the aldose and carbon 3 and 2 and 3 is left. If the mannose reduce the aldehyde group, what's happened? This is a mannitol. It means the mannitol is a sugar alcohol of mannose. I write here. Mannitol, sugar alcohol of mannose. Okay? Carbon in the sorbitol, just carbon 3 is left. Mannitol, carbon 2 and 3 is left. Now, maybe it comes to exam by the separate question and they ask it how the sorbitol could be produced. How the sorbitol could
be produced.
By two ways. Reduction of fructose at carbon number 2 or reduction of glucose at carbon number 1. How the mannitol could be produced? By two ways again. Reduction of fructose on carbon number 2 or maybe reduction of mannose. Mannose also could be, see, mannose could be reduced the aldehyde group and produce mannitol because the mannose was the mother, carbon 2 and 3 was left. See again the mannose. See the mannose.
I can't remember all of
See
this.
mannose. See the mannose. Aldehyde 2 and 3. Aisha.
Yeah.
Aldehyde 2 and 3.
Yeah.
What's happened if it's reduced?
Don't worry.
What's happened if it's reduced? C 6 carbon. It will be alcohol.
Why
alcohol, and the name will be mannitol. Just the aldehyde is reduced to OH. Everything other is same.
Can I ask you something?
Yes.
Could you write down the question for this page because it seems to be quite hard.
Yeah, you see? The question is how the sorbitol produced, how the mannitol is produced. And because both of them are derived, that's very important. No, it's written here, lactone formation. What?
Lactone formation.
What is the lactone?
It's
a ketone.
You know
and
the
a
lactone.
lactose.
Lactone is cyclic ester. Lactam is cyclic amide. Lactim is cyclic
Ester.
iminol.
Immunol.
Fuck me. Say the correct one, please. I think that you need 5 minutes rest. You don't have a concentration.